This video we are going to discuss about CDMA. So actually CDMA development started in early 1989 after the NATDMA standard IS-54 was established. A CDMA demonstration to test its feasibility for digital cellular system was held in November 1989. The CDMA Mobile Station Base Station Compatibility Standard for Dual Mode Wideband Spread Spectrum Cellular System was issued as IS-95. And CDMA uses the idea of tolerating interference by spectrum modulation. The power control scheme in a CDMA system is a requirement for a digital cellular application. However, it is a challenging task and has been solved. So, in this particular TDME, what some uh, silent features of this CDMA. Basically, this CDMA, which is based on the spread spectrum technique, has following salient features. In CDMA, every channel uses the full available spectrum. So, as you can see here, um, as you can see here, these are the silent features of CDMA. That's the first one which I have read out. And individual conversations are encoded with a pseudo-random data digital sequence, and then transmitted using a wide frequency range. And the third one is the CDMA consistently provides better capacity for voice and data communications, allowing more subscribers to connect at any given time. So that is the advantage of your CDMA. And the CDMA is the common platform on which 3G technologies are built. For example, you can have it as you can see here, the CDMA uses 1x EV DO and EV. All these are the CDMA silent features which are advantages than TDM. And there are third generation standards. And this CDMA uses frequency division duplexing multi-carrier mode. Here multi-carrier implies n into 1.25 MHz channels overlaid on n existing IS-95 carriers and deployed on unoccupied spectrum. And whereas this third generation belongs nothing but CDMA 2000 includes the following things. So what I mean to say is all these are the salient features in CDMA 2000. So 1x uses a spreading rate of 1.2288 MCPs, and whereas coming to 3x uses a spreading rate of 3 times of that the 1 so data rate will be more. And 1x EV D naught uses a spreading rate of 1.28 MCS optimized for the data. So WCDMA slash FDD DS, that means wide band code division multiple axis, frequency division multiple duplexing direct sequence spreading, that means. So this has a single 5 megahertz channels which uses a single carrier per channel, employs a spreading rate of 3.84 Mbps. So all these things are that IMT 2000 system which is going to use. What are the things you're going to use it as? Access methods, organizing partners, and body of technical spec productions. In which part we are going to use which one? This table tells about. So there you can see. And coming in the next page, there you can have so basically the CDMA have the two channels, nothing but explains about the forward channel and the reverse channels. This forward channel is the direction of the communication or mobile to cell downlink path. it includes the following channels. In this particular forward channel, we're going to have pilot channel, sync channel, paging channel, and forward traffic channel. Whereas the pilot channel is a reference channel. It uses the mobile station to acquire the time and as a phase reference for coherent demodulation purpose. It is continuously transmitted by with base station on each active CDMA. Whereas coming to the sync channel, the synchronization channel carries a single repeating message which gives the information about time and system configuration to the mobile station. And whereas paging channels main objective is to send out pages, that is notifications of incoming calls to the mobile stations. The base station uses these pages to transmit system overhead information and mobile station specific pages. There you can see the overall graph, overall table for this. And whereas coming to the forward traffic channel, the forward traffic channels are code channels. It is used to assign calls, usually voice and signaling traffic to the individual users. So all these belongs to the forward channel that you can see here in the table. The CDMA channels contains forward channel and reverse channel, whereas forward channel contains again pilot, sync, paging and forward traffic channels, and the description is discussed before. And now coming to the reverse channel. This reverse channel is the mobile to cell direction of communication. That means uplink path. So forward channel is nothing but the downlink path. Now we are moving to the opposite direction of that. Nothing but mobile to cell. It's nothing but uplink. It consists of the following channels. As you can see here, two channels will be there: access channel and reverse traffic channel. So access channel is used by mobile stations to establish a communication with the base station or to answer paging channel messages. So the access channel is used for short signaling message exchanges such as call-ups, responses to the pages and registrations. The reverse traffic channel is used by the individual users in their actual calls to transmit traffic from a single mobile station to one or more base stations. So now we are going to see the possibilities of the CDMA can operate in either FDD or TDD mode. So FDD means frequency division duplex, and TDD means time division duplex is allowed for efficient use of available spectrum according to the frequency allocation in different regions. So now if we move on to the frequency division duplex, the duplex method whereby the uplink and the downlink transmissions use two separate frequency bands. You can observe here uplink is from 1920 megahertz to 1980 megahertz, and whereas downlink uh, uses from 2170 megahertz. So totally bandwidth, each carrier is located on the center of 5 megahertz wide band. So uh, we can have a 5 megahertz of nominal value that can be adjusted actually. Yes, the channel numbers. The carrier frequency is designated by the UTRA absolute ratio frequency channel number. This number is sent by the network on the BCCH logical channel and is defined by NU. That can be measured by NU is equals to 5 into frequency uplink in terms of megahertz, and ND is equal to 5 into frequency downlink megahertz. So it's nothing but NU and ND we are going to calculate. NU is nothing but 5 into frequency uplink in terms of megahertz, and ND gives rise to 5 into frequency downlink megahertz. So that makes you the difference between NU and ND. Nothing but number of channels for using for the uplink and number of channels used for the downlink. That's what I'm talking about. And coming to the time division duplex, there you can see here in the next page all these things already we have discussed about. So this is the diagram about I'm talking about TDD. So that is a technique. Time division duplex is a technique by which the uplink and the downlink transmissions are carried over the same frequency by using synchronized time intervals. The carrier uses a 5 MHz band, although there is a low chip rate solution under study by the 3GPP, that means 1.28 megabits per second. The available band for TDD will be 1900 to 1920 MHz and 2010 to 2025 MHz. So as you can see here in the diagram, so mobile forward link and reverse link is allotted for the mobile station and the base station. In case of TDD, the forward link frequency is same as the reverse link frequency. In each link, signals are transmitted continuously in turns, just like a ping pong. And coming to the frequency division duplex, in frequency division duplex, the forward link frequency is not the same as the reverse link frequency. Here we have to observe the difference between the TDD and FDD. There in TDD it is the same frequency, but in this it is not the same as the reverse link frequency. In each link, signals are continuously transmitted in parallel. FDD. Multiple antennas, multiple input, multiple not be allowed. In long-term evaluation, 4G cell phone to increase the data rate. It is difficult to make broad enough bandwidth to cover both sets of antenna spectrum. Circuit complex dynamic adjustment is required. Thank you.